Hello, fellow COVIDians. This is the QET DMRC team consisting of myself, Axel Bruns, Daniel Angus, Timothy Graham, Tobias, Keller, and Brenda. And we're here to present our paper on sharing, spamming, and sock puppeting on social media, looking particularly at Twitter. I'm going to get the slides started. We are taking an approach to understand the dissemination careers of news articles on Twitter from both mainstream and suspect or fringe news outlets. This presentation was prompted to a certain extent by some of the recent coverage that has investigated the spread of true and false news online. The problem, if it is a problem, there's been some very good articles that have come out about this, but quite often they've been over-reported, it seems to us, as showing very clearly that, as the science tagline goes here, lies spread faster than the truth. This was actually a tagline that Science itself used for this otherwise very, very good article by Vosubi et al. The problem here is that it's not really possible from an article like this and from other articles to make that much grander claim. What was studied, for instance, in this particular study in Science was only the dissemination of fact-checked stories. So stories that were clearly determined to be true or false or somewhere in between by fact checkers. But what this doesn't take into account is just ordinary non-controversial news from mainstream news outlets. And so it looks particularly at controversial news by default. This particular study also looked only at retweet cascades and not at other forms of sharing the news articles. It aggregates across all different sites, all different news sites, to look only at those distinctions between true and false news. And it looks at the entire time frame since the beginning of Twitter. There may well be some very significant differences that are hidden within the data, site by site or over time, of course. So what we're looking to do with this particular study is to delve somewhat more deeply into these patterns and to understand if there are significant site-by-site differences and how that might also change over time. So our approach in this particular paper is to develop what we've called news dissemination careers and to understand how quickly stories from both mainstream and fringe news outlets reach their Twitter audiences, whether there are systematic differences between outlets, and maybe these outlets group together according to type in some form, whether that is by their orientation towards the truth, or whether that is by the way that they're presenting, if there's differences between, let's say, more respectable and more tabloid-focused outlets or something else. And in all of this, we're particularly interested also in understanding whether there is any evidence of coordinated activity, authentic or inauthentic coordinated activity. For instance, sock puppeting, where you've got multiple apparently independent accounts that are all retweeting the same central account in order to make that central account more visible, or a practice like astroturfing, where again, you've got multiple independent accounts that are all posting the same links, the same URLs at the same time, but not necessarily in order to make one central account more visible, but just to boost the distribution and the circulation of those websites that they're pointing to. So these are the aims that we're pursuing with this, with a number of different methods that we're applying to our data sets. And those data sets I need to say a little bit more about as well. We're drawing here on two data sources that we've developed in-house at the Digital Media Research Center. On the one hand, that's the Australian Twitter News Index, ATNIX. This now has tracked since 2012 any tweets that link to an article in one of about 35 leading Australian news outlets. So whenever there is a tweet that links to one of these news outlets, we've captured those tweets, even if the tweet has been if the link has been shortened by URL shorteners such as t.co or bit.ly. And in parallel to this, since 2017, we've also been operating what we've called the Fake News Index, FakeNix. Here we're tracking around 1,400 fringe news sites that have been identified in one or more lists of dubious sources, of suspect sources. In other research, there's the Hoaxy meta list, there's the Melissa Zindas list, there's articles by Guess et al., and a number of others that we've brought together here. So we've created a master list essentially of these lists of suspect sites. And we're capturing any tweets that link to articles on any of these sites on an ongoing basis. What we've done for this particular analysis to narrow this down and give us a data set to work with is that we've selected the 4 historically most shared ATNIX outlets: ABC News Australia, the Sydney Morning Herald, news.com.au, and The Conversation, and 7 of the most shared FakeNix outlets: Gateway Pundit, Raw Story, Breitbart, Daily Caller, Daily Beast, Russia Today, and Judicial Watch. So these are, on an ongoing basis, the most widely shared domains, the most widely shared sites that we see in ATNIX and FakeNix respectively. And for the purpose of this analysis, we've selected articles that were first tweeted during the period of the 1st to the 7th of July 2019. And we've then also captured any subsequent tweets of those article URLs all the way through to the end of August 2019. We've chosen this particular time frame particularly because it was before many of the subsequent disruptions and crises that we've seen: the major bushfire crisis in Australia at the end of 2019 and start of 2020, and then obviously the coronavirus epidemic subsequent to that. For the purpose of this analysis, we're looking at a somewhat more stable news period where certainly there are other things going on, but we're not in the midst of a major global pandemic and all the changes to news circulation that that brings. In later studies, obviously, we're also interested to see how these patterns change during other time frames. For the analysis that we're going to present in a minute, we've then further filtered this data set down to any articles from ATNIX that reached at least 200 shares by the end of our time period on the 31st of August. And for FakeNix, any articles that reached at least 1,000 shares by that time period. We're making that difference because, of course, articles from Australian news organizations reach a somewhat smaller audience because they're focusing on Australian topics, where articles from fringe news organizations that operate globally might reach a much larger audience by design. But what we're interested in here is not the total number of shares that any of these articles ultimately reach, but the speed by which they reach that final number of shares. And that's what we can compare across these different sites, even though the numerical reach in the end will be different. To calculate the dissemination careers for these articles then, what we've done is to set first as T0 the timestamp of the first tweet for each of these articles that first shares that URL. And that timestamp must be between the 1st and the 7th of July 2019. We've also calculated the maximum, the latest timestamp in our data set, which will be on or before the 31st of August 2019. That's where we have a hard cutoff. And we've calculated the total number of tweets that shared each of these URLs by that final timestamp. What we can then calculate from that is the percentage of the total share count, the eventual share count for each article that's been achieved by a timestamp somewhere in between that we've called TN. So that's simply the share already achieved divided by the total share for that article at Tmax. And what that then gives us essentially is a curve that describes how much of the final share for each article has been achieved by each point in time between T0 and Tmax. And we can then synchronize all of these in order to plot these graphs against each other. What we've then further done is for each of the sites to calculate an average dissemination curve, dissemination career for its articles. And that then provides an understanding of what the average dissemination careers are per site for these sites that we're looking at here. This hopefully becomes clearer from this graph, where we're showing these sites, the 7 FakeNIC sites and the 4 ATNIC sites that we've selected. I need to point out that the x-axis here is logarithmic, so that the first part of that graph obviously covers a much shorter amount of time than the latter part of that graph does. What we're seeing here essentially are the average dissemination career curves for each of these sites, with Gateway, Pundit, and Raw Story usually achieving a much greater percentage of the total share much more quickly, and sites like The Conversation and Judicial Watch lagging behind towards the end there and getting to their final share percentage much more slowly. In fact, to single that out a little bit more, so Gateway, Pundit, and Raw Story take under 10 hours to get to 50% of the eventual share after 2 months. We've got a bunch of sites in between that consists of both mainstream and fringe news sites that generally take between 7 and 13 hours to get to 30% of their share. They all travel together relatively well up to that point, and then diverge a bit more. We've got a number of outlets, mainly the mainstream Australian news outlets, as well as Breitbart, that take 1 to 2.25 days to get to 70% of their total share. Whereas we've got Daily Caller, Daily Beast, and Russia Today that take much longer and seem to receive sort of a late boost after a week or so. So here we're seeing that this group that travels together early on ends up diverging from each other into 2 different bundles of groups later on. And then we've got the stragglers, The Conversation, which is a scientific news site, and Judicial Watch, which tends to engage in lawfare, if you like, in starting lawsuits about particular US issues. Both take quite a much longer time to get to 50%. They take 1/3 to half a month to get to 50% of their average of their total share, and have this larger kick up towards the end. So clearly the sites operate differently, but what's important here is that the distinctions are not based upon whether they're mainstream or fringe news sites, but there seem to be different types of sites within the total group that determine how these dissemination careers operate. For Conversation and Judicial Watch, we're dealing here with sites that reach a particular specialist audience, so that might in fact be the reason that they have this relatively slow dissemination curve, whereas Gateway, Pundit, and Raw Story perhaps are dealing with more rapid news coverage, and that might mean that they're much more quick to reach 50% of their dissemination curve. So put together, these are the curves that we've observed. I'll now hand over to my colleague Daniel Angus to talk a little bit more about the analysis of these curves.
Thanks, Axel. So we used some software that is most predominantly used in computational biology. The software is an R package called Growth Curver, and this is used to track growth of cell cultures and other biological, entities, and essentially model logistic curves. So those curves that Axel just showed form what we might consider to be a classic logistic function, where there's this kind of rapid takeoff, and then there's an eventual decay at the top where these news stories kind of finish their dissemination career. And so what we wanted to do was quantify some of these curves through the use of a modeling package like Growth Curver. When we do this, it allows us to then isolate particular parameters of those models and make direct comparison between those curves to say statistically whether we believe that there are differences and significant differences between them. And so in this particular graphic we're looking at here, we're focusing on the time taken for these curves to reach their inflection point, that 50% of their dissemination, news dissemination career. And so what you can see here is that when we lay out all of those sources, our fringe and our more traditional news sources in a line here, we notice that there is nothing necessarily that strikingly different between those fringe and those traditional sources. As Axel hinted, it might have more to do with the topic matter, with the particular strategies employed by these news sites, rather than the content that is inherent on those platforms and is being shared. And so from this analysis, at this stage with the data we have, I can say that there's no observed systematic difference between fringe and traditional news in the broadest sense across these categories. While we can make pairwise comparison and say that there are differences between, say, for example, raw story and the conversation, we can't make that classification and that distinction between fringe and traditional news. I'll hand over now to Tim Graham, who's going to talk through a little bit more about some of the co-tweet analysis that we performed then.
Thanks, Dan. So this analysis was taking the data sets, fake nicks and acnicks, and turning attention from the news dissemination careers to look at kind of the engagement careers of how they were taken up and shared by accounts on Twitter during that time period. So what we looked at here was trying to leverage some cutting edge approaches that have been developed in the last couple of years. So the research that we're looking at here has kind of been prompted by, well, at least two that we're aware of, kind of bodies of work by Franziska Keller et al., who's been working on looking at coordinated tweeting and coordinated retweeting behavior. And Fabio Giglietto, apologies, Fabio, for the pronunciation, and their group has been looking at coordinated link sharing. And the rationale for examining the data in this way was to see whether there was any evidence of not simply accounts sharing and retweeting and tweeting these news stories, but whether there was any evidence of coordinated sharing of these stories. And so, you know, while it would be common for two accounts to share these news stories, whether they be stories from fake nicks or stories from acnicks, what is less common or less unlikely is that they would be sharing the stories in a very short period of time or a short window of time together and frequently. And so the logic of these methods is to uncover coordination through this analysis of accounts, pairs of accounts who have been either retweeting or tweeting these news stories in a short window of time. And the time window that we use is the same that Keller et al. Have used, which is 1 minute, and multiple times. So at least, we argue at least twice. And that rules out kind of, you know, random chance encounters between retweeters. So what we wanted to look at here was how we could construct, in this particular instance, what's known as a co-retweet network, again, drawing on the terminology that Keller et al. Have developed. And in this analysis, we did a pairwise comparison of every single account in both the atnicks and the fake nicks data sets. And what we did was we constructed an edge or a link in the network between two accounts if they had both retweeted the same tweet within a 1 minute window, at least twice. So this is, I guess more formally, these networks are weighted and undirected networks. The nodes are Twitter accounts who have shared fake nicks or atnicks or atnicks news stories. And the strength or the weight of the links represents, you know, the frequency that they have been, you know, both or co-retweeting these news stories. And so again, the logic behind this approach is that this uncovers coordination, given that we're unlikely to find clusters of frequently co-retweeting accounts. So what we found is that for the fake nicks data set, there was quite a lot of what we would term coordinated retweeting behavior in this co-retweet network. So what you can see here in the right-hand the right-hand side of the screen and the visual is a co-retweet network that has over 10,000 nodes and nearly 43,000 edges or co-retweets in it. There's a number of interesting kind of properties of this network. There's some very interesting clusters, particularly around the top region, and I've highlighted or colored the nodes by their community cluster. But I guess what we'll focus on just quickly now is two clusters that are particularly of interest for us. On the right-hand side, we've got this massive cluster of coordinated accounts, and the vast majority of these are your standard kind of pro-Trump MAGA Twitter accounts. And so I guess what we can derive at a very surface level from this analysis is that there was a large scale, there is large scale evidence of at the very least pro-Trump MAGA accounts who are amplifying fake news stories. We can say that without going into any more detail. And in the middle of the network is an interesting little cluster that has quite a bit of activity, and it centers around these two accounts that I think Axel mentioned before, who were heavily co-retweeting the Judicial Watch website. So I guess we could say that in a sense these sock puppet accounts or these troll accounts were engaging in a form of astroturfing, and they co-retweeted 250 times, and 249 of those times were about Judicial Watch. So these were more or less Judicial Watch astroturfers who were just coordinating to amplify news stories coming out of that platform. Notably, those two accounts have been suspended. So we kind of observe an interesting cat and mouse game that researchers and Twitter are playing, where we often triangulate our results by seeing whether or not Twitter has suspended them, and in this case they have. So I guess it lends further credibility and validity to these methods. And finally, what was really interesting was that even though we found quite a lot of co-retweet behavior in the fake Nix data set, there was, by comparison, almost none in AtNix. I mean, the co-retweet network that we derived using exactly the same methodology, 60-second time frame, minimum edge weight of 2, etc., only resulted in 33 instances of co-retweeting between 48 different accounts. So the conclusion that we can draw here is that there is quite a lot of evidence for co-retweeting behavior in the fake Nix fringe news website dataset, but for mainstream media in the Australian context, at least, we find very little activity. Yeah, so Axel, I will hand it over to you now to carry on with the next slide.
All right, thanks very much, Tim. So to complement this analysis of the co-retweeting, so accounts, as Tim's explained, that retweeted the same tweet containing one of our URLs within 60 seconds of each other, we've also started to explore another approach to understanding coordinated activity that's looking at co-tweeting of URLs. So here we're looking exclusively at non-retweets to see whether there are tweets that appear that share the same URL, appear within 60 seconds of each other, but that are not retweets of each other. So if the same URL is being posted by two independent or apparently independent accounts in their original tweets within 60 seconds of each other, that's what we're calling a URL co-tweet. And so there's an example on the screen there of two accounts sharing the same URL within 60 seconds of each other, and that would mean that there is now, in our analysis, a co-tweet connection from the later account to the earlier account. That's how we've operationalized this definition. Now, two accounts sharing the same URL within a fairly short time frame of each other is not inherently problematic. It's important to point that out. But it becomes suspicious when the same two accounts follow the same pattern repeatedly over time. And if they are doing this, if you've got two or more accounts that all end up posting the same URLs within short time frames of each other repeatedly, then that could indicate what we've called astroturfing, where again, where the same content is being posted apparently independently by multiple accounts in order to make that account more visible, perhaps to make it trend on Twitter and so on. I need to say that this is all still very much the very exploratory part of our analysis. This is sort of extending the Keller et al. Framework that Tim's talked about into non-retweets, and this is really the first time that we've tried this on a data set, but it does provide already, with what we've got, some useful indications of non-standard activity, let's put it this way. Here are two examples that we found for the networks around specific sites. On the left, there is an occurrence around Judicial Watch, where we found this network of co-tweeting accounts that all shared the same Judicial Watch tweet URLs. What's interesting about this is that we found a lot of account names that are named something like Trump tweets, Trump undeleted, POTUS preserved, Trump retweets, and so on. As it turns out, most of the accounts in this particular cluster are accounts that have been set up to retweet, not to retweet in a functional sense, but to repost the tweets that Donald Trump has posted on his account, in order to make it possible for people to follow Donald Trump without having to actually click the follow button and follow the real Donald Trump account, so that you can keep a watch on what Donald Trump says on Twitter without actually boosting his Twitter follower numbers even further. So what we're seeing here is not so much a case of astroturfing as just a case of a whole bunch of bots that have been set up to repost what Donald Trump has posted. And because during the time frame that we're looking at, Donald Trump actually posted a link to Judicial Watch, all of these bots have now also posted a link to Judicial Watch, and that's what we're seeing here. So this is, again, not so much astroturfing in this particular case, but a side effect of all of these accounts being set up. And of course, it does still perhaps have the same consequences as astroturfing, which is that that Judicial Watch URL that Donald Trump first posted and all of these bots posted subsequently might well have trended during this time on Twitter, because suddenly there's a whole bunch of accounts that are all pushing it to greater visibility. On the right of the screen, there's another example around the conversation, which is somewhat more nefarious, presumably. Here we found that there were a whole bunch of accounts that all have fairly similar account names. They're all Cardiff Connect and Colchester Connect and Middlesbrough Connect and so on. So UK cities with the word connect or a variation thereof added on. And all of these accounts posted within a very short time frame of each other a link to the conversation. And in fact, the tweet text itself was also identical in all of those tweets, but they weren't retweets of each other. Again, here we found that most, if not all, of these accounts have now been suspended by Twitter. So unfortunately, we can't say any more about what else these accounts might have done during their time on Twitter. But clearly, whatever it was coordinated enough for Twitter to actually identify these as a problem and to remove them. So again, this is, I think, genuinely a case of astroturfing, of a whole bunch of accounts all posting the same content at the same time, possibly with the aim of making that content more visible. Why they settled here on a link to the conversation is not clear to us, but it is possible that this link to the conversation might have been the one legitimate link in what otherwise was a parade of spam tweets or trolling tweets or whatever else as well. Unfortunately, again, because the accounts have been suspended, we can no longer go back to their timelines to find out. So this is a very preliminary part of our analysis, and we intend to explore this idea of co-tweeting alongside co-retweeting further as we go. But these early results already show that there is mileage in this, and that it does point us to clusters of accounts that all seem to work in unison with each other for whatever reason. So to conclude our presentation then and sum up what we found through these multiple methods is, in the first place, that quite in contrast to some of the studies that we've seen and we've talked about early on, that seem to say that lies spread faster than the truth. Well, we're not necessarily looking at lies and the truth here, but we're looking at mainstream and fringe news outlets. And it is clear from our analysis that fringe content does not necessarily disseminate faster than mainstream news content. In fact, that the differences in the speed of dissemination, the speed of reaching an audience, whatever the size of that audience, tend to be more linked to the types of sites that we're dealing with, the particular specialization of those sites, and other factors than whether the content is mainstream or fringe news content. In fact, what our research points to is that there are different types of sites in either category, whether mainstream or fringe, and that those differences might be the main factors determining dissemination careers for their stories. This dissemination can, of course, also be strongly affected by coordinated activities, whether they are authentic or inauthentic. That's what both the co-retweet and the co-tweet analysis point to very strongly. And we have obviously uncovered some evidence of artificial boosting through both of those strategies, co-retweeting and co-tweeting. Now, all of what we've done, of course, here deals with a very limited data set still. We've looked, as I've said at the start, at stories that were first posted within a 7-day window in July 2019. We've looked at their dissemination for the subsequent 2 months. We intend now to extend this analysis to much longer term and larger scale data from our data sets, admix and fake mix in the first place, but also from other sources, to broaden this out and see whether the patterns that we've detected here for this particular data set actually hold in the longer term for these and other sites as well. And of course, these patterns may well also be affected by times of heightened activity, by acute events, by crisis events, whether that's natural disasters like the bushfires we've had in Australia, whether that's the COVID-19 crisis that we're living through right now, whether that's impeachment proceedings and all sorts of other things going on that might lead some sites and their followers to become a lot more active in sharing particular types of information. So we're now also very interested, obviously, in applying the approaches that we've developed here to more recent data from the height of the COVID-19 crisis, for instance. And ultimately, all of this puts together time series analysis, as we've shown at the start, network analysis, as we've shown with co-retweeting and co-tweeting, and of course, further close reading and manual analysis that tries to understand not just what the overall patterns are, but delves into those patterns to understand why they might be. So what the content is that's being shared, what the accounts are that are sharing it, and that means looking at the tweet text, looking at the profile descriptions of these accounts, and so on. But hopefully, through this discussion, we've shown that there is a lot still to be discovered in the dissemination careers of news stories, individual news stories, dissemination careers per site, and so on. And this will be of use to others who are interested in understanding the differences between mainstream and fringe news outlets and the changes in the dissemination of their content over time. So with that, we'll leave it. We acknowledge our funders for this, both the Australian Research Council and the Swiss National Science Foundation. And we're looking forward to further debate in the follow-on to the panel that we've organized. Thank you very much.